Shuru karu? Okay, thank you very much. A very warm welcome to the massive open online course on science, technology and society. As you know, this is a national program on technology enhanced learning, NPTEL SWAYAM course by the Ministry of Education of the Government of India. And this STS course was devised in 2017 and last 8 years or so. We have been running the course almost every year. If you look at this, the design of the course, as you know, this is a 12-week course spanning 30 hours from July 2025 to October 2025. And you will find that 25% of the weightage has been given to weekly assignments and 75% to final examination. And please don't, I'm just requesting you all not to skip any weekly assignments or final examination because that will affect your final grade and so on. When you look at this relationship between technology and science on the one hand and our economic culture and polity on the other, you will find that prior to the 19th century, how philosophy was divided into two parts, namely natural philosophy and moral philosophy. Natural philosophy is nothing but science in the present sense of the term. And moral philosophy is nothing but ethics in the present sense. Yeah. As you know, I mean, the term science was coined by William Whewell in the 19th century, and prior to that, science was known as natural philosophy. I mean, studying nature. Scientists in the present sense of the term, or natural philosophers, then are engaged in epistemological questions, and moral philosophers are engaged in ethical questions. When I said natural philosophers or scientists in the present sense of the term are engaged in epistemological questions. Epistemology, as you know, is a body or theory of knowledge, precisely because of the central philosophical and political questions that the proponents of epistemology or the proponents of natural philosophy or the proponents of science, they tend to address. Then what are those questions? What are those philosophical questions? Now, what is knowledge? What counts as knowledge? How is knowledge produced, and so on? And perhaps for this reason, it is known as a body or theory of knowledge. Moral philosophy or ethics is nothing but a study of nature of conduct, precisely because of the central philosophical questions that moral philosophers or the scholars of ethics that they tend to address. These questions include what is good, what is right, what is good, what is bad, what is right, what is wrong, and so on. My job here is not to place epistemology on a higher pedestal vis-a-vis ethics. My job also is not to place ethics on a higher pedestal vis-a-vis epistemology. My job here is to integrate epistemology and ethics. In other words, my job here is to integrate natural philosophy, I tend to arrive at modern philosophy of science. Science, the way I tend to look at science, may be an inquiry, science may be a method, science may be an institution, science may be an ideology, and so on. When I say science as an inquiry into the nature and limits of a particular knowledge. I reiterate, a particular knowledge, not all sorts of knowledge. Science doesn't deal with all sorts of knowledge. When I say nature of a particular knowledge, as you all know, the scope and ambit of a particular knowledge, subject matter of a particular. But when I say limits of a particular knowledge, by limits I do not mean limitations. By limits I mean under what limiting conditions science is practiced or pursued. As you know, I mean, even a set theory has limits. Set theory is a philosophical branch of mathematical logic. Okay. The way I tend to look at science as an inquiry or science as a method, the famous Aristotelian question, what is the method of science, as you know, elicited two rival responses from the 17th century till the 19th century. In these 300 years, what were those two rival responses? One is inductivism and the other hypothesism. Or in other words, one is empiricism and the other rationalism. Empiricism is based on experience, whereas rationalism is based on reason. Empiricists, I mean, empiricism, as you know, it was founded by Francis Bacon, and rationalism was founded by René Descartes. And for this reason, empiricism is also known as the Baconian model of scientific method, whereas rationalism is known as the Cartesian model of scientific method. Empiricists, the way they suggested that experience is the source to produce knowledge. Rationalists suggested that no reason is the source to produce knowledge. Empiricists, they suggested that science begins with observations, remains at the level of observations, and ends with observations. And anything unobservable cannot be considered science, cannot produce knowledge. In such circumstances, empiricists suggested that seeing is believing. Whatever I can see, I must believe in this, and whatever I cannot see, I must not believe in this. On the contrary, rationalists suggested that no, science begins only when we go beyond observations. I mean, that's how we become trans-observational in nature. I mean, science becomes trans-observational in nature. Empiricists, whereas empiricists suggested that no, if I cannot see something, if I cannot touch something, if I cannot smell something, if I cannot hear something, then they are not real entities. But rationalists suggested that no, you must look at the deeper entities involved in the process. For example, this place is full of proton and electron. Does it? Can we see them? We need something else, some instrument to see them. Does it imply that they don't exist? Does it imply that no, they are unreal entities? Rationalists suggested no, they are also real entities. In this sense, empiricists and rationalists, they didn't come to a point of convergence, the method of science. In this sense, rationalists are known as realists, whereas empiricists are known as anti-realists. The 20th century was dominated by, at least the first half of the 20th century was dominated by the positivistic school of thought. As positivists argued that science is distinct from all areas of human activity or creativity because it possesses a method unique to it. That is methodology. That there is a single method common to all sciences, irrespective of their subject matter. That is methodological monism. Then what is that single method? That the method of science is the method of induction. That you tend to come to a conclusion from particular instances, to general statement. That the hallmark of science lies in the fact that all scientific statements must be systematically verifiable. There is systematic verifiability. That there is a unilinear relationship between observation and theory. Putting it succinctly, theory is based on observations, whereas observations are theory independent. Observation leads to theory, but the converse is not true. Next, there must be a fact-value dichotomy. If I say this is a table, this is a fact. If I say this table looks beautiful, then I add value to it. And science doesn't believe in values. According to positivists, not according to all. Okay, that's why science is based on facts, not values. Facts do not have any value judgment, whereas values do not have any factual content. And science, being the paragon of knowledge production, must adhere to only facts, not values. After the first half of the 20th century, we had already witnessed the horrendous crimes and casualties perpetrated by the Second World War, where this kind of demarcation between science and non-science, autonomy of science, cognitive authority of science was challenged because of the kind of the crisis that we witnessed in the form of Hiroshima and Nagasaki. And that's how you will find the way the second half of the 20th century perhaps was dominated by the most intellectually stimulating conversation within philosophy of science by Karl Popper and Thomas Kuhn. We'll discuss slowly in the weeks to follow. Maybe in the second live session, we'll discuss these things. And then we'll find Popper, Kuhn, Feyerabend, and so on. Then we'll also discuss the relationship between science, technology, and society. You will find that there are three models through which we tend to establish the relationship between science, technology, and society. As you know, technology is the medium through which human beings have been interacting with nature. When I say nature, it includes both natural as well as social phenomena. Thereby, I tend to widen or broaden the scope and ambit of nature. And as I told you, science is an inquiry, science is a method. Science as an institution. When I say institution, it's a combination of norms and values. When I say science as an ideology, I mean, science doesn't remain at the level of science. Science becomes a part of a set of beliefs like Nazi science. Okay. That's why I always say, whether right or left, ideologies, they have deterring effect on our rational faculty, on our cognitive faculty. Ideologies are myths, ideologies are fantasies, symbols, inverted images, echoes of material life. In quest of truth, in quest of knowledge, one must go beyond the narrow confinements of ideologies. Okay? In such circumstances, we are trying to build the relationship between technology, science, and society. Uh, as you will see that in the linear model or hierarchical model of the relationship between science, technology, and society, you will find that the hierarchical model or the linear model suggests that science leads to the development of technology, and then technology leads to the development of society. On the contrary, you will find the interactionist model suggests that no, there is a two-way relationship between science, technology, and society. Though science leads to the development of technology, technology leads to the development of science. Society. Once our economy, culture, and polity they are developed to one extent, they also contribute to the development of science and technology. Okay. The similarity we know the difference, but the similarity between the linear model on the one hand and the interactionist model on the other lies in the fact that both these models they treat science, technology, and society as separate entities, as isolated categories. Whereas the embedded model suggests that no, science, technology, and society are very much a part of society, our social formation. The earlier notion was that all knowledge, excluding scientific knowledge, is socially and culturally conditioned, whereas today what we see that no, all knowledge, including scientific knowledge, is socially caused. Science must be seen in terms of its historical integrity, in terms of its cultural embeddedness. Right? That's why science no longer is a universal category, no longer is an autonomous category, no longer is an independent phenomenon. Science is no longer invariant, ahistorical, atemporal, and so on. Okay, the literature suggests that that science is autonomous, having its internal dynamics, unconnected with the external forces of production, is no longer sustainable. Rather, what we find is that both technology and science are affected by or are influenced by the worldviews, meanings, interests, attitudes, uh, ideologies, and the corresponding actions of the scientific community that one can empirically observe. Okay. And we also know how technology always predates modern science. Technology is prior. One must understand the dialectical relationship between technology and science. One must understand the mutual relationship between technology and science, and how and what are the implications for our economy, culture, and polity. Okay. Please don't think that I'm trying to build some kind of a causal relationship. Rather, I'm trying to build some kind of a dialectical understanding of the relationship between technology, science, and society. Okay. If this is so, and we are going to discuss further. We are going to discuss science as a social institution. I mean, ethos of science, popularly known as kudos, communism, universalism, disinterestedness, and organized skepticism, and the kind of challenges to the Mortonian John Gibbons. Then we are going to look at social shaping of technology, social construction of technological systems through the works of Donald McKenzie, U.D. Walkman, and others. And then we'll end with what's the end of this course. We are going to end with science policies in India, namely the scientific policy resolution of 1958, Technology Policy Statement of 1983, Science and Technology Policy of 2003, Science, Technology and Innovation Policy of 2013, and the new Science, Technology and Innovation Policy of 2019. Okay. I reiterate that please don't skip any exam, weekly assignment or final exam. Please, I'm sure most of you are students, some of you are faculty in different institutions. Please tell your students also for larger enrollment, so that this course, please don't think that one will only learn for grade or something, for certificate, for credit, but this course also is meant for faculty who are also going to teach in their respective institutions. If you have any question, please raise. You can raise questions here. You can raise questions on the portal also. We have a dedicated team of teaching assistants. They will definitely respond to you. If they, they of course they consult me while responding to the queries that you have posed. We all will contribute to making this course a little more interactive. There cannot be a one-way process to learn and teach. Rather, your participation is going to enhance this course. Thank you very much. If you have any question, please raise questions. Do you have any question? If you don't have any question, please raise those questions on the portal. Then our team will respond to you. Is it okay? Hello? 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 Okay. Can I leave now? Hello? Can I leave now? Okay. Okay. Thank you. Thank you. Thank you very much. All the best.